Dan Bisque. I'm one of the 4 Fisk brothers who work at Software Bisque, and we've been working together now since 1990, so almost a little more than 25 years, I guess. And if you don't recognize me by my face, you might recognize me by my avatar. So this is a drawing that my daughter, who is 7 now, she was 3 at the time, she drew, and I thought it was a good representation of my face instead of my face on our support site. I'm up to almost 20,000 posts now over the last 10 years on our support forum, so if you ask a question about Software Bisque, I'll probably be the one at least reading it, maybe not answering it, but I'll try. So that's me. Now, like I said, there's, you go ahead, advance. There's 4 brothers. Steve Bisque, he's kind of he's been called the Bill Gates of astronomy because he's such an innovator. And then Tom is the second from the right, and then me, and then younger brother Matt. And so that's in order of age there. Steve's 54-ish, and 49-ish. So what do we do? Go ahead, hit next. I forget, we have one more addition to the family. This is Richard Wright. He's an expert in OpenGL. He was a professor at Full Sail College. He taught OpenGL there, and he's now on staff with us full time. And he caught the astronomy bug, and now that's him at the Winter Star Party, surrounded by Software Bisque equipment, and that's the witch head that he acquired this year at the Winter Star Party. Anyway, he's become kind of our being a teacher. He likes to get out in front of audiences, whereas the Fisk brothers, we abhor it. So I thank you for putting up with me tonight. And Richard's, he did the iOS version of the Sky for the most part, and so he's become a valuable member of our team for the software development side. So go ahead. So I thought I'd take a quick look back at Software Bisque, where we were and how we got to where we are today, and it kind of gives an indication of where we're headed for the future. So back in 1981, older brother Steve was playing volleyball in the backyard of a friend's house. He went down to get a ball and landed on some lawn egg. Well, it ends up that he tore up his knee so bad that he was in bed for 2 months. And while he was sitting in bed, he decided that he would write the first DOS-based planetarium program, and the first 7 characters he typed were the sky, separated by an underscore. At that time, Pascal programming language, he separated variable names with an underscore, and so that's where the underscore comes from. And so from 1983 through about 1990, he sold the Sky out of his basement. You can go ahead and advance. In about 1987-88, he decided to combine an optical encoder with his computer running the Sky for DOS, and this little box, it's called a B-box, he had developed that took the encoder output and turned it into serial input, and he could all of a sudden quickly manually move the telescope around, and with the aid of a computer, he could find objects. And it seems like a trivial point now, but at the time, everyone made fun of him. All his friends, his coworkers would say, why would anyone ever want to take a computer out to a telescope? And so the answer is, they do now. So that kind of got us into the integration of that technology, got us the integration of the astronomy software with the hardware. And so you can go ahead and press next. In 1990, I graduated, actually in 89, I graduated from School of Mines, and my younger brother Matt graduated from Mines later in 1990. And Steve hired us both out of college, and we spent the next few years porting the Sky for DOS to the fledgling Windows 3.1 operating system. And at the time, Steve had been doing custom financial software, and he hired us not really knowing what we were going to do as a company, but knowing that we could work as a team together. It started selling from this ad. It started selling really well. We thought, gee, this is a nice endeavor. Maybe we can actually make some money at it. And so we kept improving this guy. You can go to the next slide. So in 1994, 95-ish, we had a defense contractor approach us because the telescopes that he was trying to use, commercial telescopes, couldn't accurately track the satellites that he was trying to track, and he needed an alternative. So we had been developing the Paramount mount, and once again, this mount, the basis of this mount is the Sky Astronomy software. And they bought the mounts, and as the title there says, the first 4 we sold tracked spy satellites. Well, that's true. And they started getting good results. And we learned the lesson of the key to a good mount is precision gears. And these original Paramount, it's called the GT1100, the original mounts had buyer's gears. We bought our gears through Ed Byers, and he would come out and visit us every once in a while. He was at the time the world's foremost, and probably still is if he's still around, considered one of the best gear makers in the land. And so the Paramount kind of launched us into the track of integrating software and hardware to increase observatory productivity. Next slide. And so in the years following, from 1996 to today, which is a big leap, we went from the Sky version 1 to the Sky version 2. We skipped the Sky version 3 to version 4, and then we went to version 5, version 6. We developed a Windows CE version of the Sky, and it's now obviously the whole technology that Windows and Microsoft had developed for handheld computing is obsolete because of the iPhones. So we put a lot of effort into that. It didn't pan out. The SkyExPro was kind of the stalwart application for a lot of observatories. People still use it today, and they do not want to let go, kicking and screaming to the latest version. So the SkyExPro is still a venerable software. Then we are now shipping the SkyEx that started shipping in 2010. We developed a 3-dimensional solar system simulation software called Seeker. It's just an amazing piece of software, but for $49, you kind of can't give it away. It's just not, our core audience doesn't want to purchase that product. So it's kind of fallen by the wayside. The other products that we developed, the Paramount GT1100S was a DC servo motor version of the GT1100, and it improved the speed of the slews. CCD Soft, we developed with SBIG to control SBIG cameras and do some image processing. The application called Orchestrate was yet another application that integrated the control of the telescope and the camera from the Sky and CCD Soft. And then we also developed the Paramount ME in 2000, which was the 3rd generation of the Paramount mounts. And so we have all of these products that we've developed over the years. Go ahead, click next. And our product line has now kind of settled down in that we have the core product is the Sky Astronomy software, and it comes in 3 different editions. The student edition is for students. It's used in a lot of observatories as part of their curriculum. Serious Astronomer edition is for those who want telescope control, and it has larger databases. You can also add the 2-point add-on to the Serious Astronomer edition. And then the Professional edition, that's our flagship product. That's what, in terms of software use, probably 98% of people using the Sky use the Professional edition, and the rest of the 2 or 3% is the other editions. And so it's our core set of customers throughout all the time using their telescopes. The add-ons, so essentially all the software that used to be disparate applications that we try to get working together under Windows, we now have integrated into one application that works under Mac and Windows. And stepping back in 2007, we made the decision to get away from the Windows operating system reliance and rewrite all of our source code in a framework called Qt or Qt. And it's cross-platform, and it's enabled us to go to Mac and Windows. Qt now supports Android and the Windows Phone, and we do have a Linux version of the Sky running too. So that's kind of opened up the doors to spreading the technology of the Sky and the capabilities of integrating the software with hardware of different computers. So the camera add-on is the software that controls your camera and your focuser and your filter wheel and AO device. and it's just activated from the sky now with a serial number, and so it gets rid of a lot of problems that we had under Windows maintaining multiple installations and multiple applications. T-Point, how many are familiar with T-Point? So the T-Point software was developed by a professional astronomer. His name is Patrick Wallace in the UK. And essentially, T-Point is used on every professional telescope in the world to improve pointing and improve tracking. And so Patrick, for the last 40 years, has devoted his career on taking pointing data from a telescope and making it point accurately. And so that same code now is integrated with the sky, and it makes for a really efficient observatory when you slew the telescope, and you can be sure that it's going to be very close to the center of the field of view. Another optional add-on that we have is the dome add-on. So if you have an automated dome, as the telescope slews, you can slave the dome opening to the telescope. We also have some entry-level products. Oh yeah, go ahead.
With your dome add-on, there's a whole bunch of different types of dome doors, slit doors, etc. There are roll-off roofs, which kind of open you up to the sky, and you don't need to worry about it afterwards.
Right.
And then there are doors that cover the whole slit and slide sideways, or open up this way and slide sideways. And then there is a class of observatory domes where basically what's open is an aperture, and the aperture can move, and you can think of it as an Altaz telescope with really gross pointing characteristics. How many of those types of domes can you deal with?
The special sauce there is the dome controller. So all of the features and functionality, there has to be a dome control system that has the logic for being able to move that aperture to a certain azimuth and a certain altitude. And so once that dome controller has that capability, then the sky can, provided the dome controller has a serial or a USB interface, the sky can speak to that, and no matter where the telescope is situated inside the dome, you can set up the dome geometry parameters, and provided the dome controller has the ability to move in azimuth and altitude, then the sky can work its magic and move the dome with the
So the dome controller speaks azimuth and altitude.
Yeah, exactly.
And you can simultaneously drive a telescope in equatorial coordinates and your dome in Altaz coordinates.
Yep, exactly. Yeah.
Okay.
So it makes a slick interface. Some of the new applications that we have the Sky for iPhones and iPads, and we also have a free application on the App Store called Gas Giants, and it shows you the positions of the moons of the gas giants or any time. So we've kind of gone from DOS-based to Mac Windows, that's a Mac screenshot of the sky there, to the tablet. And the problem with the friction with going to the tablet in the niche market that we are in is there's no way that the tablet can do all of the heavy lifting that it takes to control the camera and the focuser. There's just downloading the image, there's just not the horsepower there. And so we're working, we have a solution to fix that problem. So our hardware products, for stepping back, in 2002 we had the Paramount ME, and for 10 years that was pretty much our one and only hardware product. And since 2011, we've completely redesigned all of our mounts, and we've introduced the Paramount MX first, and then the Paramount ME2 is redesigned with the rounded curves instead of the square-looking shape. And then the Paramount Mighty we introduced last November and started shipping that. And so with all of these mounts and the tripods and the accessories and the Bisque telescope control system that you and I were talking about earlier, we need efficient production capabilities. You can go ahead. Okay, so this is a view of the Paramount ME2 versus the Paramount MX there, and we've gotten some really good reviews in the Sky Telescope and Astronomy. You can go ahead and click next. And here's the ad that's appears in Astronomy Magazine as a half-page ad in Sky Telescope Magazine now. That's my hand. So it's amazing what Photoshop can do.
You photograph my man.
Pardon me, yeah. And the interesting thing about the ads we take out lately is all of these are renderings from SolidWorks. We don't hire a photographer. It used to be we'd go up to a professional photographer in Boulder and spend a day having him take just the right picture with just the right lighting. Well, now we can do it all in software through SolidWorks. And so that's a SolidWorks rendering. And all of our hardware now is designed in SolidWorks so that it can be quickly taken into CNC machine code. And it's given us the ability to increase our production probably 4 or 5-fold. So the next slide is what I was getting to earlier. So 3 years ago, we moved into this building. It's on the north side of Golden. If you drive on Highway 93 ever, you drive past Spider Co. and there's a car wash there. Anyway, we're just behind Spider Co. Right by the hog back there. And the office building right next to the warehouse where we have our machine shop makes it so our developer, who happens to be Steve Bisque, he designed the new models of the Paramounts. He can design a part in SolidWorks, walk over to our machinist, hand him a disk or put it on the network, and within hours we can have a part made, custom made, and it's really helped the efficiency of making sure everything's designed well. Go to the next one. And here's a picture I took this week. We've got all new CNC machining centers in the last year. We've invested in them to increase the production, and wow, it's really working. We're able to make production runs in just a few months now, whereas it used to take us a whole year to make one production run at the Paramount. So go ahead. Yeah. So understandably, with all of these mounts, we sell a lot of them. There's a lot of parts. Those are brass nuts that we machine to go on the end of the worms, and these are Paramount Mighties that are just about ready to go out the door. Go to the next. And these are Paramount ME2. This is our assembly area at this shop. Stainless steel counterweights, aluminum parts. I think we're now the #1 recycler of aluminum in Golden. We are ahead of Coors now. So they used to be ahead of us, but we go through a lot of aluminum shavings. Motors. I was talking to Stuart. The motors in all 3 mounts are the same, and so we can essentially buy a lot more motors, reduce costs that way, and gain efficiencies of having one set of replacement parts if things go wrong. So what do you do with our mounts? This is a picture of Paramount. Make sure I get the model right. They look all the same. That's a Paramount MX with an Officina Stellari. I believe that's a 10-inch, and a QSI camera. That's one of Richard's setups at a star party or campsite somewhere. The lower left photo there is the 4 goofy-looking Fisk Brothers in their uniforms when we were featured in the Scene in the Dark documentary back in 2007. And Timothy Ferris had us wear light-colored shirts with those khaki pants, and we laugh to this day. Anyway. So this is Paramount ME2, and I hate to admit this, but I have to tell the story. So we delivered 10 of these systems last year to the Air Force Academy. They're being set up all over the world for student outreach and teaching cadets about astrometry, satellite tracking, all kinds of different astronomy endeavors. And 0.5 meter telescope. There's a lot you can do with it. Well, when we set up this system, first of all, that's about 600 pounds of counterweights and telescope. This tripod wasn't designed to carry that weight. So when we took the telescope off, and you can't tell anybody this outside of this room, it's very embarrassing.
Turn off the camera.
We had a little problem with the tripod. Anyway, led to a redesign. The tripod's only designed for 300 pounds, and we had 600 pounds on it. That's what you get for pushing the limit. Go ahead. Here's another system. This is the Dragonfly system. If you've got $175,000 burning a hole in your pocket, you can buy one of these systems. It's 10 Canon telephoto lens. They're f2.8. They're $10,000 a piece. And on the back side is the S-Bisque 8300. They're $3,700 a piece. So what they do is detect and measure ultra low surface brightness on galaxies, and they're out of it's the University of Toronto. I have to look at my notes because it's the Dunlop Institute of Astronomy and Astrophysics at the University of Toronto, and they are publishing a lot of papers and making a lot of discoveries of low surface brightness objects in galaxies that has never been detected before. So that's another application of high-end application research that people are using the Sky and the Paramount for. This system is set up to do some satellite tracking for classified satellite characterization. There's several different projects here in my notes that I was supposed to refer to that research and development type things that people are using the Paramounts for. There's the prompt system in Chile. They do gamma ray burst follow-ups. There's the M-Earth project. MIT is looking for the extrasolar planets, and interestingly enough, the first 3 months they set up a system of 8 Paramounts in New Mexico. They found one, and so they got a lot of good publicity, and they got more funding, and I think they have a site in Chile now. Another project is the Global Jet Watch project. There's a professor at Oxford, Dr. Catherine Blundell. I don't know if anybody's familiar with her. She has set up telescopes longitudinally productive in that she can observe outgassing from microquasars in the Milky Way 24 hours a day. And she's engaging students in these areas to help her measure and detect this outgassing. And so she's done some pretty fun work with the Paramounts there. Next.
I have an irrelevant question here.
Okay.
That airplane was in the previous slide.
Uh-huh.
What the hell was it? Is it?
I wasn't there. I think it's.
There's not that many high-wing multi-jet planes around. Is it 2-engine or 4?
4.
It's gotta be
I believe
4.
it's got 2 on each side, so that would be
Okay.
4.
It appears to be lacking a horizontal stabilizer. Is that just a?
The horizontal stabilizer's on top.
It's on the top.
Yeah.
Oh, you ought to see part of it sticking out somewhere, it seems like.
Yeah.
That makes me nervous.
It's right, you can just barely see it in the picture right up top.
Up there.
Okay, I see, all right, way up there.
I don't know the history of that particular. I don't know if this is maybe Edwards Air Force Base or.
It doesn't look big enough to be a C-141, but then again, I could be wrong.
So we're still doing a lot of work with the satellite tracking and the classified satellite characterization. The U.S. Space Agency, they gave us a nice plaque saying, "We like your stuff. We can't tell you what we're doing with it, but we like your stuff." So. This is the Software Bisque Observatory. We had this built a couple years ago, and we just finally got final from the City of Golden. It passed its final inspection. Hallelujah! So we'll have a really first-class research place to set up equipment. Software Bisque doesn't do astronomy like most astronomers. We're not out there to take pretty pictures. Pretty much all we want to do is set up the telescope and make sure the system works within specifications. And we really haven't had time to pursue the finer points of astronomy, like pretty pictures or photometry or those kinds of things. So this is the observatory at Software Bisque, and hopefully we'll have some outreach and some of you can come visit.
That would be great. That would be great.
Yeah.
Let us know when the doors open.
Yeah, so I'll kind of speed through this. There's a lot of button pressing here. So the SkyExPro and the add-ons, what does it do? Mac and Windows. It's 3 simple words, but it took us 7 years to rewrite all of our source code, and it was a big investment and a big risk on our part, but we're glad we did it because it's opened up new doors in amateurs who love Macs and won't go to Windows and in research. The Sky has a lot of standard astronomical database. You can fly through these. The Parcos Tycho Guide Star Catalog, they're old, they're dated, but you gotta have them because there's so many references in the literature for them. The PGC catalog, it's 1 million galaxies that are all cross-referenced from different catalogs. The Sky comes with a subset of the UCAC catalog, and one of the problems we're finding with the Sky is that we have these databases that are 8 gigabytes, 80 gigabytes, 40 gigabytes, and we can't offer download access. We're not Google and Apple, and we can't afford to have the download access. And so what we've done with the native catalog is offered a database add-on, which I'm getting ahead of myself. So the other catalogs, of course, NGC, IC, Messier, SAC, Able, Caldwell, all of the popular ones. And if there's one that you find that a catalog that's not in the Sky, we make databases all the time for people because there's lots of them out there. There's thousands of specialized databases that people use. Washington double stars and the general catalog of variable stars has a complete database of those. And these last 3 bullets here, the UCAC4, the native UCAC4 supported in the Sky, it's 8 gigabytes, 113 million stars. Nomad, it's 1 billion stars, 80 gigabytes. And so what we did is we made a hard drive that has 200 gigabytes of additional data for those who have the insatiable appetites for data. And it also has the 10x Palomar digitized Sky Survey photo set on there. That used to be a $3,500 set of 101 CD-ROMs back in the day, and now you can get it for cheap, or you can just download it from the web, pictures one at a time. So in addition to the standard features, we've got a lot of advanced features, and so this gets into the integration of Software Bisque software with all of the different hardware out there. Can you, back up one. So ImageLink and All Sky ImageLink. ImageLink, we were talking at dinner about, you can submit a photograph at Google of an insect, and the Google engine will find all of the related insects and guess what kind of insect you found. Well, ImageLink works kind of the same way in that you can go ahead and click next. You look at any photograph and you find an inventory of stars, and with that inventory of stars, you can match patterns of stars in known astronomical databases. And we've taken ImageLink, so once you have that pattern match, then you can do an astrometric solution, and you know the right ascension and declination of every pixel on your photo. And so if you're doing photometry work or you're doing pretty pictures and you want to register all of your photos as well as you can, ImageLink is a great tool for that. All Sky ImageLink takes ImageLink one step further in that if you have a field of view of your telescope between 10 arc minutes and 3 degrees, you can plop down your telescope, take a photo of the night sky without knowing the scale, without knowing any positional information a priori. All Sky ImageLink will find that where that photo is in the night sky. And so for initializing the telescope, when you're setting up before polar alignment, particularly for German equatorial mounts, is a great tool because you can always find yourself. Lost in space is a term that NASA used for the pattern recognition that the Hubble telescope used with the Guide Star catalog. Another fun tool is closed loop slew. It uses essentially When you slew a telescope, as you probably know, it never gets there unless you're using telescope modeling like T-point. Well, with closed-loop slew, what that does is it slews the telescope to a target object, and since you know it's not going to be accurately centered, it takes another photo. When it gets there, does an astrometric solution, then offset slews, and so generally you can get the position of the telescope slewed to within a few arc seconds of where you want it to go. And it's an expensive it's an expensive operation in that you have to take multiple pictures, but it's accurate and it's great for realigning your data set from time to time. Accurate polar alignment. This is something that we recently released in the sky, and it leverages T-point. T-point modeling, what two of the terms that fall out of the T-point model are your polar misalignment terms, your misalignment in azimuth and your misalignment in altitude. And what you can do is, once you have your calibration data, the accurate polar alignment procedure takes those misalignment terms for your polar alignment and says, turn the telescope this direction, and the result is you can get very accurately polar aligned to the refracted pole or whatever pole you want to get to in a short amount of time, and you don't have to rely on the drift method, which is a method that samples only 2 points of the celestial sphere, and it necessarily has errors based upon the geometric errors in your mount. Automated pointing calibration. So T-point requires you to point your telescope at a random set of points in the sky and record the difference in the position of the telescope and the actual position of the star. And once you have this data, you can go ahead and click next. Supermodel is a feature that we've added to T-point that takes all of that pointing calibration data and it creates a pointing model that will improve the pointing accuracy of your telescope, where most customers get pointing accuracies within 10 arc seconds RMS now, and our specification is 30 arc seconds RMS, which is about the diameter of Jupiter's disk, depending on where it is in its orbit. It's a little bigger than that most of the time, but you can achieve really fantastic pointing with automated pointing calibration supermodel really easily, and that just improves the productivity of your system. Observing lists, probably one of the most underused features in the sky, is you can create a query if you want to see all of the 14th to 16th magnitude stars of a certain spectral class in a certain constellation. You can create a query in just a few seconds and get that information. Automated or advanced features continued. Automated focus. We have a routine at Focus 2. It uses the same, if you're familiar with Focus Max, it uses half flux diameter to get the optimal focus for your system. So focus is another one of those bugaboos for digital imagers that you never know when your system's in focus, and it's a hard technique to master. Go ahead, next. The Sky has an automation and scripting model capabilities on Windows that a lot of third-party applications have utilized to make complete observatory automation software. And so if you like to write code, you can control all aspects of the sky. You can control the telescope from a script. You can do it from a JavaScript. You can do it from Visual Basic Script, C, C++, C#, whatever programming language you fancy. You can do that with the Sky, and that's a big aspect of the Sky that's used by third-party automation software as well. Go ahead, next. JavaScript engine and debugger, so if you want to play around, if you want to automate the use of the Sky, setting up your location, setting up tours, for example, you can use the built-in JavaScript. Mosaic grids, a lot of our customers take wide field views, and the Mosaic feature allows you to set up your grid over your target object and then slew through each tile in the Mosaic so that you can assemble them later in image processing software. digitized sky survey photos, go to the next one, are great for the simulators. You can set up the sky with a simulated camera, a simulated telescope, and have the simulated camera download the digitized sky survey images for the area of the sky that you're looking in. And you can do automated point calibration runs. You can set up your observing list and do a lot of simulations. So before you head out to the observatory, you can make sure everything's going to work right. Device support. This is something we were talking about earlier. The camera add-on is expanding its device support. We have support for RoboFocus, Starlight Express cameras, Canon cameras, FLI, most of the major camera manufacturers, and the more popular focusers, filter wheels, and rotators. And one of our big focuses, particularly Richard Wright, has been to get cross-platform Mac and Windows support for these different devices under the sky, so we don't rely on any third-party software to do that. So, where are we going from here? I have to look at my notes. Seriously, the automation portion of the software, there's a lot of third-party programs that have done complete observatory automation, and they're Windows only presently. There's nothing available on Mac or Linux, and so we are actively pursuing automation and developing software so that you can take a lot of the fun out, and probably preaching to the wrong choir here, but take the fun out of the observing in that you can set up your script the night before, go to bed, wake up, and you have your data. And a lot of our customers these days, they don't want to take the time to go out in the middle of the night and get eaten by bugs or freeze their nose off. So they like the prospect of that. We're going to continue to improve and expand our hardware offerings. We have a few things in mind. Since we have the Goldilocks of mounts, small, medium, large, this one's too big, this one's too small. We might be going up and we might be going down, but we're going to go somewhere. Improve and new products. And basically, our goal has been and will continue to be to make observing and acquiring digital data easier and to empower astronomers to just make their life easier. So that's it.
How many software designers do you have?
So there's me, I can hardly be called a software designer anymore. 3, essentially. 3 and then a part-time.
Do you ever let them see the light of day?
Well, it's me and Matt and Steve and then Richard. So those are the 4. But I'm kind of like what's the bottom feeding? I go through the software and make sure the communication, what it's trying to present to the user is correct, and control through to clean things up. That's kind of been my job lately. I haven't been doing this serious programming like we used to do in the early days.
That's pretty
Does your standard software require a worset alignment to work, or is it just defined based on a constellation? Like it's database organization or whatever?
So, and I'm not quite sure I understand the question. So essentially with the sky, you input your location, date, time zone, and it shows
Figures out where it's at its own pretty much?
Yeah,
Okay.
yeah. It's for any date and time, 4713 BC to 10,000 AD. So, yeah.
Maybe if I ever get
Any other questions?
With T-point, is there a way if you have 2 telescopes on the mount to have 2 different T-point models with resident within the
Yeah,
system?
so essentially the model is saved in a settings file, and so you can load the different settings file for the different telescope.
Is that in your
So that's,
book? I mean, the
yeah. Yeah, if you look under T-point settings in the T-point add-on user guide, and anyway, I can try to, if you send me an email, I can show you
okay.
where that is. Go ahead.
Do you still use buyer's gears?
No, so we've, using the modern CNCs and what we've learned over the last 20 years, our gears, stepping back, we made the specifications for the Mighty, the peak-to-peak periodic error. The precision of a gear is measured in its periodic error, basically. And the specification for the larger mounts is 7 arc seconds peak-to-peak before periodic error correction. Well, generally, with our new techniques and the high-end CNCs, the periodic error of the Paramounts is around 5 arc seconds. We set the bar a little higher for the Mighty, thinking that we couldn't get as accurate gears because when you work with smaller gears, it's harder to get as accurate. Well, a lot of Mighties are coming in at 2 arc seconds peak-to-peak periodic error before correction. So
Before correction.
yeah, before correction.
That's impressive.
Yeah, it's just so the accuracy, the processes that we use to create the worm and the gear are so precise now that it's producing really good fruit there.
And most of the stars any of us see are like 3 arc
Yeah,
seconds
exactly.
in size
The
anyway.
scene around here, yeah, our observatory is kind of seen strangled in that you can't exceed that around here.
But there are places where you can.
Yeah, exactly.
How long does it take to make a mount from beginning to end? Just if
So we can generally make 100 in 3 months. So
So is your, could you give us a rough idea of the breakdown of your current market? Obviously, you're selling a lot of these the software and mount systems to the big guys.
So
how much
amateurs are our core market, yeah, by far. Software is probably 50-50 mount software breakdown, but our core customers, generally the Paramount customers, are becoming our most lucrative. You know, we're in the market. We're a private company. We're in it to make profit. And the most profitable is making the mounts and selling the suite of software with it. And so that's kind of forcing us in that direction.
to the amateur.
To the amateurs.
To the amateur market. Well, it was interesting when you came out with the Mighty because that was smaller than your previous mounts
Yeah.
and more in line with what amateur imagers are kind of needing. It kind of looks like.
Yeah, and
Smaller
it's
telescope.
just surprising how many amateurs are out there who have a $100,000 observatory. It's just amazing.
I guess I'm not in
Anyway, so there's a lot of professional doctor, lawyer, retired types who they want to get into imaging. They want to bypass the learning curve and head straight for the precision robotic telescope like the Paramount.
But you also are making larger telescopes. Your largest telescope is now the ME2.
Yeah, the ME2 is a payload capacity of 240 pounds, and so the total capacity of double that. So yeah.
Is there any more room on the end of that shaft for more counterweights?
Yeah, so we actually have a counterweight shaft extension that you can put on. But we just for a project just in the last couple of days, we now have 40-pound counterweights.
Your standard size is 10,
Yeah,
20.
so they're 10, 20, 30, and now we have 40 pounds. So that impressive number will go down because they're counterweights. But stainless steel is so expensive that we kind of have hesitated to get into. You have to buy so much at a time, and it gets really expensive to
Oh yeah.
find.
Most of the other manufacturers, well, let's say the mass manufacturers, which you're not, you're a premium manufacturer, they're using powder coating, they're using plain steel and powder coating. Is there a reason that you stick to the stainless steel? Is it prestige or?
Yeah,
Or
I mean, not
are there
prestige
really-
is in the whole picture. Stainless steel is the best, the least resistant to wearing. Powder coating breaks off, paint chips off. Stainless steel can rust, but you can remove it with rust remover. So anyway, just the design of the mount screams for a precision counterweight, and we're not going to use
So it's just a matter of keeping the quality consistent.
Yeah, so we
across the
actually
entire-
experimented. We had planned with the Mighty to make a powder-coated counterweight, and it just wasn't durable enough. So.
I see. Interesting.
I understand machining would probably be horrendous, but you could always go to a denser material like tungsten.
You could.
Like I said, machining would be horrendous, I realize that.
Now that incandescent light bulbs are out, there's probably a lot of tungsten around.
So Daniel, my name is Ken Sturrock, and I appreciate you answering all my stupid questions online. But you and Matthew have been very helpful to help me write a bunch of OSX scripts. So I was very intrigued to see that you are trying to push the automation more towards OSX, because my wife would very much like it if I would stop cursing in the study. So is there any kind of a timeline on that, or should I hang up my spurs, or?
I hesitate to give a timeline right now. We made really good progress, but I'm not going to give a timeline. But it's actively in the works. I'll give you that.
I'll just pay attention. Thanks.
You'll know.
Is your facility open for tours?
Yeah, so we can arrange a tour. That's for sure.
Okay. I don't have a piece of paper to send around, but if those who might be interested in touring their manufacturing facility, if you will drop me an email at vp@denverastro.org, I'll collate those and try to set it up within a reasonable time.
Well, I'd like to see it.
So my children are homeschooled, and so the homeschooling group that we belong to, they come out, and the parents were fascinated, the kids were fascinated, and it's just seeing a manufacturing facility like that in the United States, hands-on.
People generally don't know where their stuff comes from.
Yeah, exactly. It's just, you walk through the shop and you see taking a raw block of aluminum and turning it into that. It's just remarkable. Yeah, it never grows.
Well, I'm glad you do the school tours. That's great.
Yeah.
Well, we'll get together a group of people, and if it's too large, we may have to break it up into.
Okay.
I'll talk to you about it. Great.
Did you always manufacture in-house, or was there some critical point?
There was a critical point, yeah. So the first model, that GT1100 in 1996, they were manufactured in Florida. And we realized very quickly the parts would come back, we'd have them shipped back, we didn't have a manufacturing facility, and things wouldn't fit together, and you'd have to pound, and it just was not conducive. So the buyer's gears, of course, they were all precision, but then the rest of the supporting skeleton wasn't there. And so we realized quickly that we had to set up our own shop.
If you want it done right, do it yourself.
Yes, exactly.
Are you and astrophysics friends or competitors, or?
So, for mutual respect, yeah, they're an amazing company. The products they produce, the variety of products they have, it's just, you can't argue with their success. So, of course, we'd like them to go out of business, and they'd probably like us to go out of business. I think it's better for both of us. It's a competitive field, yeah, and we push each other.
Astrophysics can't go out of business because they've got too long a waiting list for their company.
That's right. And I mean that in all jest. Yeah, we see Roland and Marge at star parties all the time, and they're really nice people, and they were just impressed all get out at their quality of their products and what they put together.
Where do you stand accuracy-wise between them? You know, like they're 1600 or something. Is it comparable, or are you outstripping
The Paramounts are the most accurate mounts in the world. I mean, period, bar none. With T-point and the telescope modeling, and with the precision gears, they're as accurate as any mount available. Now, if you want to get into the on-axis encoder discussion, which the Paramount ME2 in a few weeks will have optional on-axis encoders, you still have to have telescope modeling software to get rid of atmospheric refraction. You can't fix atmospheric refraction by an optical encoder. You have to do that through software. You can't fix tube flexure. When you mount a large telescope on here, unless you're in space, it's going to bend. And T-Point figures out that bending in the tube flexure and the unbending and compensates for it. And if you don't have that modeling software, you can't fix all of the fundamental problems in a mount. So when apples to apples, the Paramount's periodic error will stand up to any gear-based mount in the world. And when you put in periodic error correction, it's generally, unless you're on a mountain in Chile, it's generally the periodic error is less than you're seeing. And so all total, the Paramount should be as accurate or more accurate than any mount.
So basically, there's a limit to how accurate you can make the mount. And
Yeah,
you have to make it more accurate by your software.
through software. And that's why T-Point is such an asset. And that's why having Patrick Wallace, so Patrick, he has about 1,000 posts on our forums now. He regularly looks at amateur systems. He analyzes pointing calibration data, and he is just a wizard at saying, okay, here's what the problem is. Your optics are flopping 10 arc seconds when you go from north to south, or whatever the problem is. Somebody with a high-end, I can't remember what lens it was, just this week Patrick said, yeah, something's flopping, and it turns out the image stabilization of the lens, the telephoto lens he was using, was causing the mirror to flop, and you could see that in the calibration data. And he was wondering why he couldn't get better than 60 arc seconds RMS pointing, and it's because his mirror is flopping. So,
Okay, can T-Point recognize the flop and compensate?
well, so there's nothing you can do about hysteresis. It's just a random error. It's like noise in CC image. You can't.
Hysteresis?
Yeah, hysteresis, backlash, slop.
You don't know when it's going to
Yeah, you don't know where. So all you can do is mitigate hysteresis through mechanical means and try to make it as repeatable as possible. Yeah.
Yeah.
Oh, sorry.
How difficult was it to go from a software company that you started into making hardware? I mean, it seems to me
So,
that would be a really
For
tough
instance, when
jump.
we first set up our machine shop, we didn't have any experience first hiring machinists to run. And so Steve, Matt, and I would spend our nights running the machine shop, learning how to get that going. And then during the day, we'd go to do the software. So it was a difficult period. We bootstrapped it. We did what we had to do. The gentleman who designed the Paramount ME, he designed the Astrophysics AP 1200, Rob Miller. And so he was our machinist at the time. And so he would set up the machines, and we'd come in and run them during the night shift.
Was it a financial motivation that you needed?
We like to
that
eat.
Software
Yes.
really wasn't
Well, so a lot of people, for example, when we first made the Paramount GT1100, the company who made the control system told us to abandon the project because they didn't see any market for a high-end robotic telescope mount. And a lot of times the brothers look at each other and say, why are we doing this? This is probably the hardest application of combining a myriad of camera and optical equipment on a mount and make it all sing together. It's almost impossible. It's like we're both bullheaded and we're not so smart, as my father is.
I wouldn't go there.
Are you coming up with annual licensing fees? I think I got hit with one sometime.
Yeah, so the software, the way our software used to work is we'd go 5 years without an update, and then we'd have an update, and that model just doesn't work for us. And so we've gone like Adobe and ACP and Maxima DL and a lot of the Microsoft, a lot of the software vendors in the industry. You have to get that recurring revenue, or we just can't afford to maintain the changes. And it's been very beneficial in that we now have a daily build, and that daily build is sometimes there's a 2, 3, 4 week hiatus, but we're able to apply a lot of resources to developing, and we sit on our support forum. We try to address issues that come up. There's issues between Windows 8, Windows 8.1, Windows 7 alone versus Yosemite, snow leopard, lion, all of these things, different operating systems come together, and just that alone, maintaining software is an ongoing task. And then the Minor Planet Center will change a URL, or they'll change how they make their satellites accessible, not their satellites, their comets and asteroids, and all of a sudden our support site lights up because of something that's out of our hands, but people rely on getting that data through the sky, and so it's a juggling act of keeping the software going. Any more questions? I could sit here all night.
Well, let me just make a comment here. Dan told me on the phone yesterday his wife is hosting. I think the story is his wife is hosting a bridal shower tomorrow. He can't stay with us very long tonight. So if you have any more questions, let's go ahead and ask them now and let him get back home.
Brenda thanks you. Go ahead.
Just a simple one, what's the capacity of the lighting?
50 tons. Yeah, so it goes 50, 100, and 240 is the breakdown of the three models.
I don't think a C14 that's been kind of.
Yeah. Here, don't forget.
That's
got all
guard down. Or?
Yeah, sure.
Is there any export restriction on some of your technology because it's going to be looking at things in the sky?
No, provided you don't use GPS timing technology on it. Yeah, so I'm trying to remember the outfit, the government that restricts. I'm drawing a blank. Anyway, one time a system we put together had accurate shutter timing to the billionth of a second with the time frequency processor, and that was a restriction, so that's not allowed. But otherwise, just the software and the mount, there's no problems, no restrictions. Good question.
On the iOS versions, how is it equivalent to which level of the sky?
So if your device has enough space, you can put the Nomad catalog on there. So you can load it up with sky databases. It's really not equivalent to the desktop PC versions because they do so much, and it's more of the core of the planetarium, time flowing, and telescope control.
So, but it has telescope control and whatever, same type of telescope.
Yeah. Same, and the nice thing is it uses the same drivers, the same source code as the other one.
Is this for the iPhone you're talking about?
Yeah.
Any more questions?